Traditional porting tools are proven. With the right machine, the right setup, and the right cutting conditions, a plunge-style porting tool can produce an accurate hydraulic port form with a single operation. That's why shops use them. They're efficient, repeatable, and built around the port standards the fitting has to match. The challenge is that a plunge-style porting tool can ask a lot from the machine. It's not just opening up a hole, it's forming multiple features at once. Chamfers and cone angles for sealing, counterbores or spot faces for fittings, and blends and transitions for fluid flow. Depending on the port size, material, and geometry, this can put significant demand on spindle power, torque, rigidity, coolant delivery, and setup stability. So what do you do when the port still needs to be accurate, but the machine is not ideal for a heavy plunge cut? The only options used to be to slow down the cut, move it to a heavier machine, or send the work out. Then we thought, what if we could combine the load-reducing benefits of milling with the accuracy and repeatability of a porting tool? We got to work and developed the scientific cutting tools, Port Mill. The Port Mill gives shops a more flexible way to produce hydraulic port geometry. Instead of driving a full-form porting tool directly into the hole, the Port Mill uses a milling strategy. It interpolates the port form and removes material progressively through the tool path. And this changes how the cutting load is applied. Rather than concentrating the work into one axial plunge, the Port Mill spreads that cut across the milling path. Material is removed more gradually, which can reduce load on the spindle and make the operation more practical on machines that may not be suitable for conventional plunge-style porting. For shops machining hydraulic manifolds, valve bodies, and fluid power components, this can offer a huge advantage. It can give you a way to keep porting work in smaller, vertical machining centers, reduce dependence on larger machines, and keep more of your work in-house. The Port Mill is not a shortcut around port standards. It is simply a different cutting strategy for producing the geometry that those cutting standards require. Same level of accuracy, just a different method of getting there. Traditional porting tools will still be the right answer for many applications. When the machine and setup can support the cut, a plunge-style porting tool remains an efficient way to produce the full port form. But when the machine or setup are limited, now you can reach for a Port Mill. Scientific Cutting Tools has built porting tools for hydraulic, aerospace, and fluid power applications for decades. The Port Mill applies that same understanding of port standards and geometry to a milling-based process that can fit a wider range of machines. If you're machining hydraulic ports and want to know whether the SCT Port Mill fits your machine, material, and port requirements, contact Scientific Cutting Tools or visit sct-usa.com to learn more.